Chromatography is the process of using polarity to separate a mixture. In chromatography, there's a mobile phase, or a phase that moves, and it can be a liquid or a gas, and then there's a stationary phase, which can be a solid or a liquid. Each component of the mixture would separate based on its attraction to the mobile phase or the stationary phase. So if the polarity is more closer to the stationary phase, then it will end up sticking to that. If it's more closer to the solvent that you're putting the chromatography through, or the mobile phase, then it will follow that. So in this sample over here on the right hand side, we were able to separate these three compounds based on the polarity. We had some that are very nonpolar, and that middle one has a little bit of polarity on its little tail. So you can see that just that little tiny bit, it was able to travel faster with the mobile phase, and so you're able to separate these components out. In this class, you should know how to do paper chromatography. And so you take a piece of paper and you mark your starting line, and you put a small dot of each mixture about a centimeter from the bottom, and then you suspend the paper with the bottom edge in the liquid, and this liquid will travel up through the paper through capillary action, and as it does that, it's going to take your sample up with it. Some will stay behind, some will go right along with it on the solvent front, and then some will be right in the middle. So this is a really cheap way to separate out a mixture, just to put a small sample in to see what you have. In this class, we're going to be separating food coloring or marker ink, and those pigments are easily separated. We can calculate what's called RF, or retention factor. It's a ratio of how fast a component of a mixture travels versus the mobile phase. So at the bottom, you're going to have the distance the liquid traveled, and at the top, you're going to have the distance the color traveled, or your sample. And here's a diagram right here at the bottom how to do it. So it's important that you have your starting line marked, and then when you take your developed chromatography paper out, you want to make sure you mark the end, because that is going to be your bottom number. And it doesn't matter if you measure in inches or centimeters, because we're going to divide it out. But this is measured in centimeters, so I would do 2.8 centimeters here at the bottom. So that's how much the solvent traveled. And then my little dot moved up 2.1 centimeters. And so I'm going to get a fraction. You should always get a fraction that's less than 1. So I end up getting 0.75. And there's no units. It's just a ratio. So if let's say this was an antibiotic, and I could figure out the retention factor, I could look it up and see what antibiotic it would be, because I'd have this ratio.